Welcome, everyone. It is a great pleasure to welcome this evening's keynote speaker, Michelle Addington, who is both the Dean and the Henry Rockwell Chair of the University of Texas at Austin School of Architecture. Formerly, she served as Gerald Hines Chair in Sustainable Architectural Design at Yale University School of Architecture. I'm going to continue without my video. Apologies here. Where she was also jointly appointed as a professor in Yale's School of Forestry and Environmental Studies. Prior to teaching at Yale, she taught at Harvard's Graduate School of Design, Technological University Munich, Temple University, and Philadelphia University. Michelle has a fascinating career leading her into architecture, as she was originally educated as a mechanical nuclear engineer and worked for several years at NASA's Goddard Space Flight Center and DuPont before she embarked on studies in architecture, in part which include a doctorate in design from Harvard, as well as an honorary MA from Yale. Her teaching, research, and professional work span across these disciplines with an objective of determining strategic intersections between the optimal domains of physical phenomena with the practical domains of spatial, geopolitical, economic, and cultural systems. She has authored numerous books, chapters, essays, and articles that address topics ranging from fluid mechanics to the history of technology to smart materials. And she has consulted on projects as diverse as the Sistine Chapel and the Amazon rainforest. In 2009, she was selected as one of the country's top 10 faculty in architecture by Architect magazine. And in 2014, she was named as one of Connecticut's Women of Innovation. Let's have a warm welcome for Michelle Addington.
Thank you all so much. And I'm hoping now that I'm plugged in and everyone can see me, even if I'm actually sitting in an empty office, looking only at a screen. This was an interesting talk for me to prepare, and there's a reason why I called it Research Redux. A lot of it has to do with the opportunity, or perhaps the lack of opportunity one has to participate in research as a dean, their own research as a dean, but does have to be involved in the much larger research enterprise of the entire school. But it's also Research Redux in that I would say that I have a checkered history with research. What I learned by osmosis, what I learned incidentally, what I tried to learn purposefully, what I taught. I would say I have so many intrepid doctoral students who put up with me through years of trying to sort of figure out new approaches and different ways of going about research. Some of them were, I say, startling in how extreme they were. There was a time when I required every one of my doctoral students to pair and seek out someone in a field completely other than theirs, and hunting down Nobel Prize winners in fields like theoretical physics. In order to do this was just a really onerous and difficult task, and all the more difficult for the students who were involved, all of whom I think forgive me for what I put them through. And all of whom actually have had pretty remarkable careers in spite of how messy a lot of those processes were. But there was a time when I was sure I knew how to do it. I was sure that I knew how to do it better than anybody else. And the older I get, the more I see what's out there, what's not out there, the more I question not only how I participated, but I question the very methods and the very structure that's behind the way that we approach it. So right before I get into this, I've got to give my litany of thank yous as everyone else has. This has been an absolutely amazing conference. So, real shout out to Claire Robinson and Beth Weinstein on putting this together. It's not easy to do a conference like this to begin with. It's extraordinarily difficult. It's so many moving parts, so many individuals, so much that one has to do to sort of deal with subjects that many people may not be as interested in or engaged with, but they're actually critical for us to have discourse on. The breadth of this is absolutely amazing on this, but to do so in a way that it's so beautifully organized, that the keynote speakers, certainly the first two were amazing. That has been absolutely fantastic. And I also have to give a great thank you to great thank you out there. I'm sorry, I was told to receive texts if anything was wrong, and I'm just quickly checking to make sure that nothing is wrong in the presentation. So, because I don't really have any way of interacting with anybody other than my relatively empty screen at this moment. But I also want to give thanks to ARCC, Chris Jarrett. Chris and I had conversations many years ago, and special props to Hazem Rashed Ali. Hazem cornered me about a year and a half ago, told me and shamed me into getting more involved with ARCC. And I'm grateful for that. And I hope that I will continue to be involved in this as we move forward. So this opening slide probably has an image that you could guess would be Austin during its recent blackout. And that's going to become important as we get toward the ends of the lecture. But basically, it's to sort of set the tone for how we define our purview, what we leave out of our purview, that we don't get to sort of like isolate ourselves into sort of like things that we define as belonging to architecture, that the products we define as being architecture, that what we do has consequences and impacts often far afield and in ways that we're not always sort of fully aware, sometimes not aware at all of what those impacts and what those consequences will be. And for all of the stories that you heard about Austin during this time period, heard about Texas during this time period, it was almost entirely about the way the electrical grid was managed. It was not about the way that we have had unchecked development and the pace of development that's taken place. We have a hand in this as architects. But I was going to start this, and I'm kind of breaking this talk into two parts in here. And the first part of it is actually sort of reflections on things that I think are issues with the way that we think about research. Things that I've noticed are observations that I've had over the years. Some I recognized recently, some I recognized quite some time ago, but they're really sort of like pointing out what I think are key aspects that perhaps sort of keep us from building the robust research infrastructure we need to build. And I think the end of it is actually going to turn into a more affirmative move forward of where some possibilities may indeed lie for us going forward. I will say that there will be things in here that some of you will strongly disagree with. There will be things in here that you'll disagree with, things in here that hopefully will pique your interest, and things in here that you may agree with. It's going to run the gamut from that. I've yet to give a lecture in my life that I didn't receive at least some hate mail. And this is not, and when I do bring up something that you might disagree with, it is not because I mean it as an attack on one's work or on how one might be approaching things. It's more about what I think are some systemic things that we need to work on. And so I hope that sort of like puts it in that particular stage. But there's another piece to this as well, and that the Technology, Architecture, and Design Journal asked if I would do an op-ed, sort of reflecting on my path and my role in research over what has now been over 4 decades. And it was in writing that where a lot of the observations came to the ground. So I also have to sort of thank the journal for dragging me away from fundraising and writing up protocols for how we socially distant to be able to sort of think about research and research within our field. So I think the first thing that I want to point out as being perhaps one of the things that frames our field and the way we do research in a different, and I do think it's generally problematic, even insofar as I think that there are opportunities to be gleaned from it, but in its sort of current guise, it's something fairly problematic. And it has to do with, and now I'm not able to, I'm going to have to get out of this and reload this one. I apparently pulled up the wrong screen. Try sharing the screen again. Let me try that one instead. All right, there we go. The specter of the author. We think very much in our field about authorship. We think about ownership within that, even insofar as we're actually a stunningly collaborative field in terms of who participates, who we team with, who we speak with. We're incredibly collaborative. If we think about it, we still rule by authorship. We still think about a signature, whether it's a signature on a building, a signature on a piece of research. And we tend to sort of teach the way that we research, and we tend to sort of act on a lot of our research as if it is to be the original work of a given author on this. And I also sort of need to put a little bit of a caveat or a disclaimer on this. I'm dealing with the kind of research as it gets into particularly technological performance. I'm not talking about historiography and history within this. I do think they have a very different kind of research ecosystem than we have in technological research. So I'm going to keep this sort of more focused on technological research on this. And the specter of the author comes in to haunt us, in many ways, but it also sort of like stems from origins that we have to start to repair before we can actually sort of like climb out from under this umbrella, under the specter. And so if we think about what would define the way that we would sort of like start to describe research in any set of disciplines, it really falls into these 3 modes, as most of us well know. What the research ecosystem is, which starts with the academic structure of how one, particularly beginning at the graduate level, starts sort of like gearing that graduate level, and in many cases that graduate level, not necessarily not in architecture, but certainly in most of the disciplines, that graduate level, that first master's degree, is actually meant to be a first research degree. In our field, that first master's degree is actually in many cases a practice degree, but in most fields, it's meant to be sort of your entry point into research. But we think about sort of like the robustness of the entire structure, from the way that master's programs are defined to the way that PhD programs and doctoral programs are designed, to the way postdocs are in place, to the way that plugs into what the academic research would be of certain types of institutes, of certain types of units, of certain kinds of faculty on certain topical areas. It's a very dense structure in many disciplines. What that looks like. For us, it's spotty. We don't have the kind of breadth that one might have or any kind of sort of like unanimous idea about what a research master's degree looks like. I have one, many of you have one, many of you are studying one right now, and each one is sort of designed and defined in a different way. Many of them aren't intended to go on to doctorates, but by the time we get to doctorates, which are fewer programs, they also too tend to be more distinctive in relationship to the place where one is studying, less about what we would consider to be sort of common questions or a unified approach within our discipline. It's spotty in numbers. We don't have a critical mass there. We don't have agreed upon structure there. So we're already missing one of the most important pieces of it, which has to do with the academic structure. And of course, that pulls into what we consider to be institutional governance. And I don't necessarily mean just the institution that one would deal with in terms of the university. It's also sort of institutional governments, such as what we would find, for example, from the National Institute of Health or the National Science Foundation, different types of entities or bodies that we also think of as touchstones, as clearinghouses, as purveyors of research, and often in many cases sort of like the primary support or the primary funding mechanism by which many of these academic enterprises take off. But the other part where we're also sort of really missing is that a really robust research structure goes all the way back to basic research. It understands the role of basic research, sort of developing the fundamentals, and what that path is to applied research. We tend to sort of like exist, at the very sort of tip of the applied research standpoint, particularly when we're talking about technological performance and technological research. We're looking to fix a problem, have something that gets instituted into practice. We're not stepping back to ask the very fundamental and basic questions that we should be asking. And then, of course, if we think about canon, which we define as disciplinary knowledge, very, very clear for us in architectural history what canon is. And it's something that is oft discussed. And actually has been fascinating, certainly in the last 30 years of the very robust discussions that have come out on that canon, particularly dealing with decolonization going on, which is something that hopefully we'll have a little bit of an opportunity to talk about. We don't have what we consider to be disciplinary knowledge, particularly when we start looking at when we're dealing with technologies within that. We have practices, we have precedents, we have different things that we have borrowed from different fields. But if someone were to ask you, what do you consider to be canon? I don't think we could construct that. And it doesn't matter that I've spent the decades that I have in this. I don't think I could construct what I think canon might start to be. I don't think I could construct what canon is right now. And within that then, and this becomes a really key aspect, what is commonly held, and by commonly held, sort of agreed upon as state of the art? Because state of the art is what defines the platform for which all contributions must relate to, must come to. Do we have any kind of sort of common agreement as what we consider to be state of the art? And because of that, we also sort of missing a lot of what we consider to be an understanding of methods aligned to question. I would say that the majority proposals that I review and the majority of dissertations that I sit in on actually tend to cobble together multiple methods to do different pieces of things. There might be someone who did a survey method to get a couple of ideas as a starter, then do some empirical work, a little bit of analytical work, and sort of rope that all together. You're not going to find that in other disciplines. It's good and it's bad. And again, we're going to talk about that, but not having a method and not having a family of methods that we are trained in, that we understand, and we understand the limitations of those methods is also something that we're missing on this. But I'd say one of the most difficult parts that we deal with is what is the delivery path or the deliverable and how it makes it out there. We think about governed dissemination as being peer review, but without what we consider to be a commonly held state-of-the-art, peer review becomes ad hoc within this. Test bed and or provisional platforms, this is probably one of the areas where we've seen this interesting participation by firms with their own research branches. If we think about, what happens with Kieran Timberlake, for example, and many other firms that have their own sort of research arms, they're basically creating a test bed or a provisional platform to test out an idea, sort of like develop it further from an idea standpoint into something that might be implementable. But again, spotty, focused, in terms of sort of like discrete sets of things that can happen like that, difficult to follow through on, difficult to take to commercialization if it is a series of one-offs on that. And so what ultimately we're missing is adaptation or adoption pathways for research. How do we take something from a project, from a great paper, and actually turn it into something that is out there making a difference on this? And so this is why the specter of author looms, is that if we think about this entire structure and the holes that are in the structure, the sort of the lack of foundations that are in the structure, we really are leaving it up to each researcher, each group of researchers to construct their own narrative, to sort of like pull together that which they think will take them forward on that. So we haven't created a system that allows us to sort of escape the narrative or escape the author, even insofar as we might lament it. And in some ways, we can think about it as being very entrepreneurial in terms of the kind of astonishing ability that so many within our field have to find a way to develop a method, experiment with a product without having this structure there to truly support them. But just sort of to kind of take you on this sort of idea of narrative, and this sort of steps us a little bit away from technology. But we also think about narrative in a way that we've all been trained, in the way that we are extremely comfortable writing papers where we put forward an idea, we develop an idea. I used to love my theory classes because I felt like in my theory classes, I could really take together all of the references that I had read and pull them together in this sort of very, what I thought were cogent and coherent way of explaining something or putting something forward within that. We're very comfortable doing it. I'm not sure I know of another set of another profession out there that is as comfortable being the author as moving forward. But the authorship comes with a real downside sometimes. And this is just sort of, I have some odd examples that this is populated through this. So I hope you bear with me as I kind of move from different kind of example to different kind of example. And it starts with this one right here. It's the Seagram's building. Much has been written about the Seagram's building. And, I'm going to talk in particular about the lighting of the Seagram's building, but much has been written about it. And generally, when people talk about the lighting of the Seagram's building, the interpretation or the way someone reads this building is that, it was designed to be lit. It was designed for its image at night, not for its image in the daytime, its image at night. That it was designed to actually sort of serve as a beacon, to serve as an architectural icon, sort of like, framing that around it. There will be discussions about the horizontality of the planes of lights or the strata that you see in there. I've read numerous things that talk about how this was designed for the night. So something very interesting happened on this. And so, by the way, this is just an example of showing that the intensity of the lighting is only on the perimeter. So this is part of what people saw, took this particular image, took the image of the building at night, completed the narrative that this was designed specifically in order to sort of create this reading at night. So a number of years ago, Dietrich Neumann was putting together an exhibit about Richard Kelly. If you don't know who Richard Kelly is, stop listening to me and look up Richard Kelly, basically the lighting designer of the 20th century, every modernist icon in this country, every work by Cern and by Kahn, all done by Philip Johnson, all done by Richard Kelly. It was absolutely astonishing. But in putting together this exhibition, Dietrich got a hold of the archival notes on the building design, and particularly the archival notes of Richard Kelly. And as we were going through this, some really interesting things showed up in the notes. And the first thing that showed up in the notes was that the entire approach to lighting was done for the daytime. And this is sort of a drawing that came out sort of demonstrating what the idea was, is that the brightest point was going to be the floor to ceiling glazing. The next brightest would be this sort of like strip of lights that runs the perimeter, against the perimeter. And then it would be staged down from there. And of course you can see it from a photo taken, originally just a few years after the building opened. You can see the lighting on the perimeter in that perimeter band that goes around the building. You see as well sort of that it's daytime, and you see the stepping down on it. And there are long notes in there about why it had to be designed this way. And it really was entirely about the fact that Kelly, and this is why you have to study Kelly, understood how the eye saw. He understood how he may not have known the terms for light mapping on the retina and contrast in field of view, but he described the fact that this was a way of staging the light from the brightest beam of the facade, sort of coming down to, by the time you got to the interior of the building, it needs to be darker. Otherwise, having that kind of level of light coming in. And so having that narrative flipped completely on its head was sort of an indication that we tend to, it's surprising how much of what we do is colored and affected by our ability to be an author, our ability to write a narrative. And it's caused me to question a lot of assumptions that I've made as my mind had completed a narrative simply based on sort of like the many fields that we all study and we're engaged in as architects, and sometimes unconsciously we complete that narrative as author. And I think author comes about in many different ways, but the second place we really deal with, and it's, I think, part of the straitjacket that we have that keeps a lot of our research from being as exploratory and as impactful as it could be, is how closely we hew to precedent. And I just even thinking about this, it reminds me of, we get manifestos every now and then from students of things that they'd like for us to change. And my favorite one came last year, was a group of students said, please, we don't want to have to see any more Peter Zumthor's Baal's project used as a precedent in all of our classes. Just stop it for a year and see if you can come up with a different precedent. But precedent sort of looms for us in many different ways. And part of it is that it's not just what we study to be precedents, but we like to produce precedents. And so that might be in terms of things that are meant to be demonstrations, things that we look to for being best practices, what we consider to be a baseline. Should it be a model that we emulate? Strategy can be a precedent as well, a strategy to adopt, and forms and systems to appropriate. Part of the straitjacket of this is that without actually sort of like, having worked through what it is that we are looking for in these precedents, we attempt to sort of adopt them and hew to them wholesale. And we complete that narrative about what their impact is going to be. I've now sat a couple of times on the AIA Top 10 Green Buildings Awards. And I had, when I was still teaching at Yale, I had my students analyze the winners every year and actually sort of like begin to extract from the winners and then sort of actually work out the analysis of whether or not something was effective or not. And we ended up sort of discovering, and we did this over, we actually did 10 years worth of these analyses, that was surprisingly little was that effective in terms of, although there were some things in there that were really quite astonishing. The things that were astonishing that were done were not particularly foregrounded. It was just that everything came in together. And so being used as an example to emulate or as a model to use, you were left with this whole list of strategies that you were told, well, these are the good ones that make a building sustainable. These are the things that you should adopt. And we see this throughout anytime we look at different kinds of building databases that are all meant for us to be, here's a building in your climate zone. These are the good things that building did. These are things that you should consider. These are strategies. These are technologies that you should consider adopting and including. And again, in so many cases, nobody ever worked out the math. Nobody sort of like carried it all the way through to its conclusion. And nobody sort of has ever dealt with the fact that you cannot generalize buildings just because they're in the same climate zone or the same building type. You can make a tiny change in two nearly identical buildings next to each other and have radically different performance. So the thought that we have a database of things that would be generalizable without explaining what the variables are in terms of the generalizability, instead attaching to strategies, is one of the ways that we really do go awry. And as a profession, not as a discipline, because it's not so endemic to what we do academically, but as a profession, we have not served our field well by continuing to sort of talk about what are example or demonstration projects within that. We also sort of like have a great love of the vernacular, of indigenous strategies, of the vernacular. It is something that I see probably more than anything else, that if something existed that was pre-modern, and I say more than pre-modern, that it must have really worked. And so these are good things for us to emulate and good things for us to adopt. And again, the vicissitudes of simply having an electrical infrastructure renders almost all of these strategies as either not applicable. The vicissitudes of sort of the other types of things that we have to bring to bear renders most of these strategies not applicable. And many of the ones that do work well are in climates that also are not transportable or transferable to other locations, that there's a particular type of odd high pressure zone caused by the location of a mountain range that allows a certain type of effect to occur that simply you cannot make happen just because you think that you need to copy the form of that. And I think that's what sort of like emerges from a lot of this. It doesn't matter whether we're dealing with building forms that we know, or for example, going to natural forms and biomimicry that we deal with. One of the things that sort of keeps us trapped with so many of these precedents is that we want to treat all of these things as if they're about form, as if they're about the sort of like the language that we operate in when we make a building, when we design a building, and that language is form. And so we don't look at phenomena. We hope that phenomena attaches itself to form. If I make a thermal chimney that looks like where I'm pretty sure a thermal chimney works, then that same form or sort of same ideas of the thermal chimney will work where I move it to. And most of the phenomena that we try to deal with, that we need to be dealing with, are things that actually are quite decoupled from form. But form is our language, form we make, and form we want to be, the sort of the guide that we have moving forward with this. And so we often don't extract from these precedents some of the really provocative things that we could be extracting from them, because we want to translate it into the thing that's tangible, the thing that we actually make on this. And then this sort of leads us to what I call the problem of the pavilion. I love pavilions. I always visit every school's pavilion project when I go to visit, and I've seen quite a few. But we really love pavilion projects in terms of being demonstration projects. And I mean it both specifically and as a general class of sort of identifying a thing that we make, again, a tangible form that we make, which is supposed to sort of like be our way of testing methods, be our way of testing materials, be our way of sort of like addressing certain kinds of issues of fabrication. So this is sort of now getting into being a little bit of a personal story. But a number of years ago, on one of my sabbaticals at Yale, Technical University in Munich, asked if I wanted to come and be a research chair for them. And I'm thinking, cool, I'll do that. I'd love to be a research chair in emerging technologies. They had a lot of PhD students I was looking forward to working with. I arrived, and then I was told that in 3 days I had to have my studio ready to go. And I think I was kind of thinking I'm on sabbatical. I really wasn't going to teach a studio, but it turned out, I said, no, it wasn't in my contract either, that I had to teach a studio. And by the way, you build a pavilion in the studio. And I thought, kind of not my thing. I'm a thermal person. I do micro machines. I do lots of stuff like that. I really don't do pavilions. There's a lot of people who do pavilions. It's not me. But they were pretty insistent on that. And this is just sort of pavilions that occurred before me and after me. And the one in the middle was the one that was still up when I arrived, that I was shown that our pavilion had to be better for that. Well, I just, part of me, it wasn't that just that I didn't want to do pavilion. I honestly don't know how to do a pavilion. It's not part of my move. So what I wanted to do, if I was going to be teaching a studio, I wanted to take a seminar that I developed at Harvard and then took to Yale that was looking at questions of perception, particularly in terms of sort of this, one of the things that had become really interested in me, and you can start to see there's a thread going through this talk that is trying to sort of decouple phenomena from form. Well, very much of this sort of question about perception was beginning to understand that what we see is not what we understand that we're seeing, where we think something is, what we think something might be, is not sort of like one and the same with the surface that we're making. So everything is about a decoupling sort of like perception from surface on that. And so we always did these small experiments, whether it was at the GSD or at the Rudolph building at Yale. And I thought, if I have to do something on the size of the pavilion, then we're going to do big installations of this in Munich. And so that was the path we took. And some of the results were quite remarkable. This was Donald Gork, who was using fairly high-powered projection to basically create these virtual windows and skylights throughout campus on there. And this was a particularly effective one that he created in this actually what was a kind of dark and dreary underpass, of the rail system on this. And so, we did a number of these different things. Some were really spectacular. Some were pretty lame. It was a whole gamut within that. But when it came time to do the book from the studio, I was sort of dismayed when I got the copy of it, that they took the one project that looked the most like a pavilion. And so Donald's work, who I thought was just should have been sort of a highlight, and it was all part of the narrative for the studio about this sort of like not being about form, but being about perception thereof. And then much of the book was focused on the one student who was so disappointed we weren't making a pavilion that he basically made a pavilion on there. And you know, so yes, this was a personal thing on there, but I look at a lot of these projects and I think there could be something gleaned from this. I don't know what it is. And that is sort of the obligation or the weight that we have. You know, is this the most strategic way to sort of like foreground a particular phenomenon? Is this the way that you truly want to leverage sort of like teaching a new type of technology, experimenting with a new kind of fabrication method? You know, is this the way of kind of doing a bunch of things and actually sort of like, you know, indulging, which many students love, in design build? I'm okay with all of that. I want to know what it is. And I think that the onus is on us to sort of ask what that is. This to me is something that I see a lot in projects, particularly in dissertations that I look at. It's what I call the conflation of method. And it's kind of like the evil twins or the first cousins between the noble intention by and then the straw man argument at the end. What I mean by the noble intention by, and this is particularly true for those of us who work in sustainability, but also many people who are working on affordable housing and different things of great social import, is that if your research is about that, you don't have to explain any more than that. You know, so if your research is about sustainability, you go do your thing because you already said it was about sustainability, therefore it is. And of course, the straw man argument is sort of at the end of it in terms of you don't actually have to demonstrate how it's going to be used out there because it exists, therefore someone's going to figure out that it could be used out there. So we kind of deal with it on both ends of that. Basically short shrift on really posing a hypothesis and a question, short shrift on sort of like taking the conclusion to its sort of next steps of, you know, how it appropriately sort of enters into what we consider to be, whether it's modes of dissemination, modes of testing, or modes of implementation out there. So much of what I see in many of these projects, many of these sort of research things, I did the book. The book means it's been disseminated, therefore it's had an impact. The book is just a beginning, sort of like your first vehicle in getting it out there. You still have to sort of begin to make that argument on that. You know, so again, for sustainability, so many things will say, you know, particularly I'd say wood has been very, very popular. It has been popular for a long period of time. And so supposedly the work is couched on wood is a sustainable thing. Wood is carbon neutral in a sort of a very bizarre accounting scheme. Wood will save the planet. My project's about wood. Therefore, my project is indeed addressing questions of sustainability. It's not. It's addressing questions of how to make a wood building within, you know, sort of certain questions about sort of constructing in wood. But the very virtue of the fact that it's a project with wood does not tie it either in the beginning or the end to any kind of sort of question of sustainability, unless you actually sort of like make that argument. And so this kind of leads me to a discussion that I had with Darren Walker. Darren Walker is director of the Ford Foundation. And I was chatting with Darren on one of our visits, you know, just saying, you know, it was after I'd become dean. And so I was sort of changing my role. And, you know, I wanted to talk about why the Ford Foundation, you know, wasn't more involved in supporting work done in architecture, because we touch on so many of the areas that are key. And Darren's response is that, you know, The projects are one-offs, and they never connect the project to what their goals are, to what the needs are, to what the actual initiatives are at the Ford Foundation. It says most of the things that get proposed for them as architectural research or architectural projects are things that assume that once the book is written, once the exhibition is prepared, that its very existence means that it will be used by somebody else who will figure out how it's going to have an impact. Or if it's an exhibition, people will see that and they'll become more aware of the thing that the Ford Foundation is doing. And Darren's response to that was, that's my job. You know, my job is to make people aware. Your job is to actually sort of come up with the ideas that will make a difference on our problems, not sort of like be part of telling the story about it. Although I imagine we could do a very good job at helping there, but I was really taken by that particular conversation with him. I'm still working on him. I'm still working on trying to get some architecture projects funded through him. This is probably the one that stresses me the most right now, and I think I needs to move a little bit over to the left, but you can start to see it. The overdependence on proxies. Part of the way that we skip through having to sort of like ask an important question is actually sort of like latch on to a proxy. Perhaps one of the most common and most problematic proxies we're dealing with right now is the proxy of high density equals sustainability. High density sort of gives us affordability on this. It's a proxy. It's not actually. It's a proxy, and it's a proxy that actually comes out of one thing. It comes out of this fairly old study that related urban density and the energy of transport, not energy in general, but the energy of transport. And it's pretty extreme if you look at this sort of range that you see on here, from American cities all clustered over here to Hong Kong, as we know, one of the densest city in the world, all the way over here. And so it's part of that saying like, well, you know, our cities need to be more dense. That will reduce energy, and it goes from being about energy for transport and energy for a particular kind of transport to being energy in general. And so if there's sort of like any sort of proxy out there that has found its way into more decisions being made in more cities in this country, it is this push for higher density. I cannot have a conversation about our city without someone sort of like talking about zoning changes to allow for higher density, to looking at FIR changes to allow for higher density. It is a steady drumbeat, and it's one of those that is automatically associated with being sustainable on this. I mean, this map alone should tell you that it's not as much about density, because these are all cities that sort of are relatively close in density. It has everything to do with the kind of transportation systems that we have. And that's what the key difference between these cities are the transportation systems, not the fact that one is radically more dense than another, not the fact that we're going to move in this direction if we make things more dense. We'll be moving up and down if we make things more dense in this. And density comes with a lot of consequences on it. Nevertheless, you know, we've got this proxy in our mind, and it's affecting decision after decision after decision. So just sort of showing you an aerial map of Austin. And one of the things you'll notice is this sort of line moving out to the east. And actually this image is a couple of years old. So we're going to see second line moving out here, and we're going to start to see fill in here. This is one of the places that the city has its eyes on densifying. And of course, the way that and so you can see here, residential, and then these sort of like, you know, mixed use units, much loved by new urbanists. So an idea of mixed use what we call 5/1s. Actually, we call them Texas donuts, but most of the country calls them 5/1s. And those of you who study construction know that a 5/1 allows you to avoid certain types of structural and fire codes in their construction, so it makes them much more economical to put up. So this is a kind of sort of density that's being proposed, and we're now seeing not only blocks and blocks and blocks of these, but they go in because they're higher density. They go in because they're also supposedly part of making this a walkable neighborhood. Basically, all that happens is you drive from the nail salon that's in this one over to the nail salon that's in that one. Occasionally, there's a coffee shop as well, but they all manage, for some reason, have nail salons in them. And what's being torn down are the bungalows. So the bungalows that, for those of you who might have been in Austin even 10 years ago and are familiar with these, the bungalows were originally the African American community and more recently the Hispanic community in Austin. And so one after another of these are being torn down. And so this one is now gone. So I try to photograph what's going up and what's coming down on a weekly basis. And I'm shocked on a weekly basis by yet one more 5/1 going up. So the densification of Austin, and all of that densification is actually sort of being predicated on the fact that it's doing good, that it's meeting sustainability guidelines, that it's creating dense, mixed-use, walkable neighborhoods, even insofar as no one's walking in them, that it's doing all the things that people believe are like the hallmarks of making this more sustainable. So we did a quick study, and it turns out that the average apartment in the 5/1 uses more energy per capita than the average bungalow did, the average occupant did in a bungalow. So does it look better on a block by block basis? Of course, it looks better on a block by block basis. But when we talk about people being served, we're actually sort of increasing the energy use. But that's not the proxy that people use. The proxy that people are using is actually higher density on this. And then sort of looking at this from a slightly different way, and this is actually, these are quite recent. So there's another neighborhood, so our Hispanic population is being pushed out of East Austin as it's being completely taken over by tech bros moving in. They're being pushed now to Montopolis, where there had been a very well-established Hispanic community for generations. And this is one of the cemeteries that they have there, the San Jose Cemetery. And I toured the seminary with some of our students and city council a few weeks ago. And what you notice, it's a little hard to see here, but this is all now in relation to Elon Musk and his desire to make Austin the next boom town. But he's part of sort of like this rush to the city. These are warehouses going up. They're using the cemetery as landfill, as sort of like, as a dumping ground. So this was dumped on a number of graves there. And so I said the students have been in documenting on this. And we actually see a student over here photographing. And here we are. This is someone who has been in this neighborhood for 3 generations. City council woman Vanessa Fuentes is right here. And we're having a conversation about the fact that in Austin's desire to, develop as fast as it can, that this neighborhood has all been rezoned for 5/1s. 5/1s and industrial use. So it's all going to be wiped out. Some of these families have lived here for generations, but it's sort of like the last piece of this Hispanic community that's near Austin, and it'll be erased soon. And Isabel, who's a 3rd-year undergraduate in architecture, was talking to me, and she said, she loves studying architecture But this makes her think she doesn't want to be an architect, because if she's an architect, she has to want to build. She doesn't think you should build here. And the comment I had for her was actually one that I heard earlier in the conference, also from someone else. And I'm glad to hear that there's more people who think like that. Our job as architects is not simply to build buildings. Our jobs, our real job and our real sort of responsibility are to be stewards of the built environment. And as a steward of the built environment, sometimes we build, sometimes we don't build. And we have to take that full responsibility there. And so this one proxy is kind of weaving a path of destruction and yet disabusing anybody that it's not part of the moral good of sustainability is an almost impossible argument to make. There are times when high density is really useful, but I see it as a parametric slider. There are many things that have to be considered along with it to understand whether it's sort of, and weighing the benefit it does with some of the harm that it does. So that's sort of through sort of that piece of it, and I have to check on my time here. So I just sort of wanted to sort of finish with things for us to be thinking about, and kind of pulling together that we don't get to say that we just have this piece of it, that we're just working on this thing. Our questions really matter. And sometimes that question for our research is something, and I actually believe should take up the majority of the time that we're on the research. It keeps us from making, it keeps us from producing, but a well done question is unbelievably powerful in terms of what it can put forward on this. I love this sort of set of statements, and I'll make sure that I'll add the source I took it from. In my hurry, I forgot to put the source down, which makes me actually a really bad researcher. But all the ways that we should be thinking about what kind of question that we're going to ask. And if we go back to the specter of the author and our desire to be original and our desire to be the first, you actually go through these 15 ways of how you think about a question, what you should be researching. Most of them are replication or quasi-replication. Very little of it is sort of like the idea of something entirely novel that you were the inventor from it. And there's a lot of power in actually sort of understanding what that ground is. And that goes back to canon and understanding what that commonly held state of the art is, because that's where you understand whether you're sort of developing something, whether you're questioning something, whether you're building upon something, whether you're dismantling something, whether you're applying it in a different way. That expects sort of that commonly held ground to be there. And so just one quick example of how this can make a difference. This is one of my Master of Science students who finished last year. And she was very interested in how perception sort of, visual perception sort of changes sort of your understanding of surroundings. And she found this great work by Marilyn Anderson. Also, if you don't know Marilyn Anderson at Lausanne, you have to follow Marilyn's work. She's really astonishing. But Marilyn's team has done this great research sort of showing that particular color temperature and quality of daylight actually allows people to sort of change their perception of what the temperature was. And they began to determine in numerous sort of studies with human subjects, they determined that they could actually change set points. In the wintertime, go cooler with the set point, again, depending upon color temperature, and in the summertime, go warmer with the set point if you have sort of this right combination of daylighting. And by the color temperature, they really were talking about having both north and south windows in order to sort of create that balance on that. And so, my student was really excited about this work, and, she wanted to do exactly what I talked about before, the noble intention by, and actually do her master's thesis on, showing how you can retrofit buildings to have this kind of daylighting strategy on that. I said, well, before you do that, you need to sort of like really understand what question you should be asking. And what is the important question here is not, how do I put this in a building? That's a design problem. But, why does this make a difference? And you don't get to really question their human subject work because we can't do human subject work. So question the part about just, how much of a difference it makes in energy. And so in modeling this, it turned out that what Inshi discovered from this is that this was fine for Switzerland. She was able to replicate, she tried first just replicating what Maryland did, and she was able to sort of like build a thermal model that exactly replicated Maryland's calculations on this. But when that thermal model was moved in latitude, there was a moment when it switched, and the approach caused more energy to be used. And by the time it got to Austin, it was like the worst thing you could do to a building would be to implement this thing that worked in Switzerland. And, part of it, this comes back to sort of this fundamental relationship right here that we tend to forget when we look at our precedents. We love our precedents from Switzerland and Germany. We're talking about often latitudes where Edmonton, Alberta is further south than some of the latitudes of where these things are being developed for. Solar radiation is not the key, is not the driver. But if you sort of look at the equations of consequence, and the one on the left is Fourier's law, which is about conduction. The one on the right is Stefan Boltzmann law, which is about radiation. There's a big indicator in here. When you go from order 1 to order 4 in orders of magnitude, this tells you that anything that's raised to the 4th power is going to blow this out of the water. If, again, radiation is a factor that comes into play, nothing you do for conduction matters. And most of the strategies that we have coming out of Germany and Switzerland focus on conduction. They don't focus on the impacts of radiation. So in replicating this work by Marilyn, not only did she begin to sort of, for her own self, sort of come up with this kind of relationship about what actually the true driver is, and the moment at which it switches, in terms of being the one that actually really foregrounds. It's one of the first articles that's going out there that's really talking about, it's not so much that things might be more or less important in different climates. It might be that things can be incredibly detrimental in certain kinds of climates and certain kinds of conditions. And so that began from an established piece of work and working forward on it. Now, this is where I really get Redux on you. It talks about methods, and in doing a lot of putting this together is when I realized that where I learned the most was actually in my time at NASA in terms of the research projects that I worked on there. I didn't know that I was learning methods at the time, but again, you're talking about a place where there is an incredibly robust research structure. And so methods are embedded in sort of even the way the organization or chart is put together. And so one of the things that I was working on there was actually the first thing that I worked on there. And this will, if the gray hair already isn't telling you how old I am, we were developing the first computational finite element program. It was a program called NASTRAN. So I was on the development team for this. We had these equations, these structural analysis equations. They were such that we really, it was just something that was really difficult to design, satellites, space equipment, do structural analyses of these by hand. And I did a lot of them by hand. I like to think I was the fastest square root of 2 on a slide rule on the East Coast at the time. It wasn't really acceptable. And so part of what this team was doing is, and it became NASTRAN, but we were developing NASTRAN which became the first structural finite element analysis program. And so making a translation from what was theory to something that could be applied required multiple steps. And actually you can see some of the steps. We did a lot of empirical testing, and without Nastran available to us, a computational method, it was hand calculations coupled with destructive testing. So to determine if a particular satellite design would make it through launch, we would build a test unit. This was a small rocket, but we would build a test unit. We put it in what was a 9-story vibration chamber. If it was small, it was mounted on a vibration shaker. Larger rockets would go into acoustic chambers, and we bombarded them with noise. We were looking for where they might have sympathetic modal vibrations. These are all the kinds of things. And so it was hand calculations and this kind of destructive testing. Understand that the typical test was $1 million, which was a lot of money back then and a lot of money now. If every test, in order to determine how to redesign something, cost you $1 million. So the need to have that was really critical. And then the need became really extreme when we were trying to sort of like do a joint project with the European Space Research Organization, where we were designing we were designing one satellite, they were designing a second satellite, they would be coupling together, and we were designing the coupling of that. So we were able to sort of like test our satellite, we couldn't test theirs. And so we felt like this would be the first place that we could really try out Nastran on. And these are my Nastran models of the European satellite, our satellite, and the coupling in here. And anybody who does finite element analysis will be stunned that you could look at 2 complex satellites plus a coupling between them. Think about this going through launch. And the only way we could model it and use the computer that was so slow back then, I still did a lot of the things by hand on this, 182 grid points. We wouldn't do 182 grid points now for anything other than one small component, and to think that we did that for the entire thing. But in order to do that, the knowledge that different people had in terms of sort of understanding what had to be modeled, understanding what would be sort of like the key points of stability in there. There was a tremendous amount of embedded knowledge that went into this. There was a tremendous amount of sort of understanding the theoretical approach. And I'm using the word I incorrectly here. I was basically young. My job was to sit there and calculate like crazy and be the computer nerd on this. That actual translation was actually done by the larger team on this. And so for me, sort of seeing that entire process, but also being part of those discussions about why it is that we define certain points as being fixed on this, actually to reduce degrees of freedom where we constrain things, we're all about sort of understanding what was the salient knowledge to carry forward in order to do this. And so I kind of couple it with my last project that I did while I was there, that they brought me into because of my structural analysis background. One of the reasons I left NASA is I had trained, because of the nuclear background, I always wanted to do thermal sciences. And I got pigeonholed doing structural analysis, which you can tell from my fact that I didn't want to do a pavilion. That was not my thing. But it doesn't mean that I didn't have amazing experiences there. But this is sort of like the completely opposite project. This was in the sort of like the space applications branch, where we're taking things that were invented for space and did they have other kinds of uses for it. So it sounds more open-ended. But the idea of this one was to take Landsat, the satellite laser scanning system that basically sort of allowed us to create these astonishing images and basically reflectance images of surface conditions. And it allowed us to identify vegetation, it allowed us to identify disease and certain plant matter, but obviously it didn't work for water. And so we wanted to see, could we develop something for water? And so these are those basic optics. And my job, again, I didn't design the optics for it. I designed the test, the actual units, the underwater unit, which is right here. This is the underwater unit that I put together, I built and put together, and also sort of like its sister unit, which flew in a decommissioned spy plane low. And the idea is that, well, this would be towed by Jacques Cousteau. This is actually the Calypso. It would be towed by Cousteau and his people. We would match the flight with the sort of like this, the low flying plane, and we begin to see if we could map water. Turns out, no, we couldn't. So a lot of that, work for seemingly not, except not, it opened up questions about geolocation and the need to sort of resolve geolocation, which hadn't been as much of an issue before in the way the other scanning was being done. It opened up sort of questions about sort of, different kinds of questions about how we might actually get sort of below surface data of vegetation. So sort of developed a new scanning method to actually sort of do a much better job on land. And much later on, and of course, many things would have opened this up, questions about how did we actually sort of like find ways to collect and information in water. We collect information through air and with surfaces. How then did we deal with the fluid in that? And of course, eventually that one was cracked much later than that. But the number of questions that spun off are really key. And so it was only recently that I was looking at this, that I realized it just was two methods. There was only two methods that we used there. And you could call them whichever of these things that you want. Where we're taking the theory, sort of developing this particular sort of what we call a test method through computation in order to sort of apply in a very different deductive, quantitative, analytical, or causal being from first principles, or in the case where we had something, what the heck, can we possibly apply it to this other thing? Inductive, qualitative, entirely empirical, also teleological on this. Not that anything was done without focus. This one atomized focus to a particular objective. This one's sort of like much more open-ended on it, but still interestingly constrained, still in the case of this clear beginning point and a rationale or a hypothesis, a clear hypothesis to examine. This wasn't done without having a hypothesis. The hypothesis didn't hold, but the value that we got from it was really meaningful. And it made me realize that when I taught research methods to doctoral students, I tended to overgo and overdo, lots of sort of like nuances within that. And I was looking through all of my old notes on this now. I would throw all those notes out and focus on what are the two fundamental and foundational methods. But this is what matters the most. Contributions matter the most. If we cannot tie our work, and I don't mean imply that our work connects to something, if we cannot tie our work to a contribution and show how it's moving toward that contribution, what we do really doesn't matter. We are a field that's an applied field. We are a field that impacts the public. We have to be able to take our work all the way through to fruition. And that's why I sort of bring us back to this map, we actually have way more power than we tend to think. We'll often trot out that we build, I think the number is down to 8% of buildings in this country. It might be to 7% on that. We build the most significant ones. We build the ones that sort of involve the most engagement of certain kinds of jurisdictional and governance structures. We do the things that sort of become the models or the impact on the way that those who are building the quotidian buildings will do that. You know, as a school of architecture, we're actually quite intertwined with the city, not because of where the school is located, which is in the heart of the city, but also because it's a very interesting partnership. You might know that Austin had the first green city codes, and it's the green city codes of Austin, which later became the basis for LEED. Austin really prides itself on its sustainability plan. It prides itself on its plan for affordability. It prides itself on the ways that it approaches sensible development. And we are intricately embedded within that. I and many members of our faculty are on speed dial by the mayor and by city council members. We help them with their planning. We don't do planning in the way that a professional would do it. I've advertised ourselves to the city council that we are neutral knowledge brokers, that we gather the information that we need. We help sort of like put it into scenarios for them to examine. We do not advocate what they should do, and we do not advise what they should do. We provide information. And I think that the part about advocacy is key here, in that there is an elected group that is there to do the advocacy, that we have incredible power in terms of the information that we provide for them and the resources that we provide for them. But they are provided to the elected officials within that. And in having that conversation with the mayor when I arrived is why we have an open grant with the city to be involved in a variety of different sort of like planning questions that they have. And right now it's one on homelessness, as well as a $7 million grant looking at how drones and micromobility might change the entire way that we use our city. So it varies from different standpoints. We might point to a building and say, we did that building. Actually, this is one of our faculty members did these two buildings right here, and said, this is not our problem. All the bad stuff that's happening anywhere around here, not our problem. We didn't do that, but we did. We have a connection of responsibility for everything that happens in the built environment, and not just sort of like the things that are limited to our purview. And then there are questions far afield of just how we're dealing with traffic, with infrastructure, with affordability, with homelessness. The rate at which Austin is growing, and it's the fastest growing city in the United States right now, far outpaces the ability of the massive aquifer system to handle it. And so it looks like within next 10 to 15 years, the aquifer will be severely depleted, so that the idea of water to this region is going to be a question. And of course, we're also dealing with the kinds of climate extremes that others are dealing with. Thing after thing that are affecting the world is all sort of like also happening right on us. We don't get to say, I did my building and I can't help it if bad decisions are being made in other places. We have different places that we can be involved in. And the projects and the research projects we're doing should be finding ways to connect what it is that we produce with how it is that it gets implemented and how we think about that. I'm also sort of very taken by this particular image that comes from the IPCC, where it talks about the fact that by 2040, 30% of our carbon emissions will come from concrete infrastructure. We talk more about embodied energy than we have in the past. We never talk about embodied energy in terms of the peripheral consequences of what we do. We might sort of like look at our building by itself and think about what concrete we have in the building. We don't think about how our building sort of affects the larger infrastructure around us. Again, we've got to start thinking about things like this. We don't get to say we improve something 5% and 10%. when we are dealing with sort of crises much like this. So I think what's really important for us, and I'm going to be, I just have like a couple more slides left. We've got to build a research ecosystem, and we can't build it on a school by school level. We may not even be able to build it for the collective schools that we have. We might have to go beyond that. But I think that the comments that Peggy made yesterday about sort of thinking, like, you know, that every school does not have to be sort of like the generalist across the field, that we could start building critical mass in certain areas, was absolutely spot on this. I've always been sort of like, and you could tell from the stuff from the IPCC I share, I look at all of the people that they have brought in to build a critical mass across the world, to sort of like put out cogent, coherent sort of analyses and projections going forward. I think sort of even thinking about a research ecosystem from understanding how it is also done, not so much for an atomized, highly focused discipline such as, you know, microbiology, but also thinking about it for something that is complex, multimodal, and multi-domain is what they're dealing with, is really key for us. Charting the extents. Our extents are way beyond what we normally think of as our purview. What would this roadmap begin to look like? I'm really interested in sort of building research platforms or stages. These would be sort of populated throughout this roadmap. This would be our stable, sort of like agreed upon stable ground. We'll have strength in some areas, and we'll see other areas where we need to build it. What are some key methodological pathways? I'd probably start with just the two for now, sort of like moving from these. And I love this idea of designating switches, gates, and barriers. Switches are those kinds of things that we want to strategically target, because on a switch, we can begin to make a change. How do we begin to identify what those switches are? Because they can be implemented. Where gates begin to sort of open up and sort of make visible sort of additional territory on a periphery, and a barriers hard, but that's where and time and sort of long time frame in order to do that. But that's where the radical change is really going to be. When I think about extents, I'm not just thinking sort of straightforward how we do our kind of technological research. I love the work of both Michael Bricker, who's one of our alums, and Kibele Tavares, who went to the Bartlett, and Michael got an Emmy for this set design for Russian doll. This was Kibele's thesis project at the Bartlett. Completely different ways of sort of like understanding the sort of the differentiation between surface perception, you know, and this sort of translation between 2D and 3D media within this, but also sort of like these brilliant sort of other conceptions of these sort of other possible often dystopian worlds in there. And I love my dystopian sci-fi, but that's where some of this comes from. But it's also sort of in the series of transforms that takes place that I would love it just as they sort of like stepped out there. And I still think it's architecture. I don't think this is architects doing something in another field. To me, this is architecture. I'm also as interested in how we sort of bring this back into bear. Corey Beek, who's on our faculty, you're probably familiar with the fact that, you may not be familiar with the fact that the University of Texas was the biological laboratory that discovered the spike protein on the coronavirus. And of course, its visualization did not come from us. It came from a different group. But Corey has been working with sort of a sister biological laboratory. And what they've realized is that the Petri dish of old is not terribly effective. These are new Petri dish designs for E. coli. And they actually, each sort of like three-dimensional Petri dish in here actually sort of allows for a different characteristic of E. coli to be basically sort of grown on this. And so this, as an architect out there rethinking the way that we do biological research, redesigning the Petri dish, its architecture, but also the knowledge that he brings back in is that. I think about what Sarah Lopez has been doing in terms of how ideas cross in one direction of the border and forms cross in the other direction. It's a fascinating piece of work. And then I was really fortunate last year, my last trip I made before COVID, visiting El Paso, and Ursula and Stephen, who I had seen on the list as attendees from Texas Tech, talked to me about their border work there. Very much relates to a lot of what we saw from A.L. Weissman yesterday, whose work, by the way, blows me away in terms of the specificness of its problem and beyond on that. And I think a fantastic example for many of us, but the ways that there's sort of like the questions that are emerging about this and the very notion of we conceive of what we build and what we don't build on this and why. And so I think very, very quickly, because I know I'm totally out of time, I have 3 minutes left, which meant I didn't leave time for questions, but hopefully we might have a little bit of time for that. When we think about a typical discipline, we think about the extent of the discipline. If it's a discipline that has profession, we think about the profession as being a subset of the discipline, that the discipline itself is more complex, much larger than what would be the professional practice of that. And if we start to think about what the products are, sort of the tangible things that leave that, they'll be throughout, that some of them will come from the aspects that are about the pure research of the discipline. Some of them will come far beyond the discipline, but that's the sort of the map that you might see. Architecture so far, and this is an overgeneralization, and I apologize for it, but if we think about sort of the discipline in architecture, we realize it is tightly circumscribed by the profession, which is tightly circumscribed by our product. Fundamentally, what we make sort of defines how we practice, and how we practice defines what we study and what we think about. We have got to sort of shatter this open. If there's anything that will change our research culture, it's not necessarily learning a new method. It's sort of not me haranguing about having a better question. It is actually sort of like shattering this straitjacket, which keeps us from both being as rigorous as we could be and as innovative and as imaginative as we all have the potential to be. If I could think about what that research sort of system would look like in terms of discipline, in terms of practice, in terms of products, I imagine something incredibly permeable, much, much larger than the purview that we have, much more engaged in terms of understanding where architecture can reside in this world and where great architectural research can reside in this world. That's my hope, because I think that we've actually we've been constrained in many different ways, and our possibilities are really quite extraordinary. What we bring to the table is absolutely extraordinary. And so my hope is that we begin to find ways to sort of like both in some ways becoming more rigorous, and yet in that rigor actually sort of expand on our opportunities. I can't believe I talked this long, but as I warned people earlier, it's particularly if I don't see people falling asleep, which is the one problem with Zoom. I can't tell who's being bored, walking out, or falling asleep. So that'll keep me going for hours. I stop now, and thank you. Thank you for your attention.
That was wonderful. Thank you, Michelle. This is so fascinating. There's so much information that we could discuss, I think, for hours. We do have a couple of questions from the audience, and I think the first question, I just want to preface our own Master of Science in Architecture program. We are identifying as an expanding ecologies because I think we align very closely with your thinking here as a kind of cohort. So the first question is, I am struck by how approaches and questions about problems change over the course of the project. And that hindsight offers clarity about the methods most at stake. What advice do you have for students who wish to discover this evolution for themselves and finish their degree?
It's very different depending upon, the process of discovery and the process of finishing the degree on this. Because, and I think this is where we can get better, where we as educators can get better, particularly if we're talking about this at a master's degree. I've often told, I'm very different with master's students than I am with doctoral students who are in it for the long haul. But I actually expect them to go through the same process. And part of that process is sort of the painful wrangling of a question, developing a question, being really clear what that hypothesis is. And I expect that it gets rewritten again and again and again, and that each rewriting of it reveals something new, opens up another kind of question in this. And the idea is to sort of go back and forth, sort of like dump the baggage of what you want to do, what you want to prove, what you want to make, and actually sort of like, finally get down to the root of the question that is truly compelling for you on this. And compelling for you, when we move into doctoral range, it's going to have to be compelling for the canon, compelling for where we think the disciplinary knowledge. But I think in your first project, finding that thing that is really compelling without leaping too quickly into methods on that. And once that question is there, the really sort of beautiful moment then comes when you realize that several different questions will allow you to tease out a different aspect of it. So I think it's a great master's thesis if it finds a way to get to a compelling question, and it starts to reveal sort of like paths that it can go down, but then they should demonstrate it just to get some experience with it. Take it down one path, because we do expect a deliverable at the end of it. That's what I would do with it. But put your joy and your talent and your knowledge into asking that question again and again and again and again. Each ask will open up a new world. And that's where it really matters in there. You've got the rest of your life. I think when you finally find that good question, you'll spend the rest of your life re-asking that same question in slightly different ways, and trying different kinds of methods on it. But we skip that question too quickly. We skip past it when we want to make something, or we want to do something, want to produce something, or we want to prove something. We skip past it way too quickly. I don't think that solves anybody's problem in doing this in a year.
Right.
Other than we get it. So
we have a couple of more questions from the audience. And also, Michelle, if you want to unshare your screen.
Oh, okay. That might help. Yes.
Okay. Back here just a moment. So the next question, can you elaborate on the advocacy issue you mentioned? I think it is critical for a researcher to be an honest broker of knowledge, as you suggest, but how do we control the human tendency to push forward ideas we may believe to be valuable for the common good?
Yeah, I think that that's a really, that one's fraught, and it's fraught in many different ways. And and I'm also a huge fan of what Peggy had to say, that if we don't think of ourselves as advocates for the built environment, that has to be, on our shoulders on this. And this becomes sort of like the interesting dilemma that we have with our research, that the research itself has to be sort of like uncoupled from our own bias. That the more that we sort of like are advocating in a particular direction, the more our own biases will come into play, that will sort of force us, or not force us, but actually cause us to cherry pick things that will lead us more directly to a position we're advocating. So to be the best advocate for the built environment, to be the best advocate for sustainability, to be the best advocate for social justice, to be the best advocate for sort of like creating an environment that is affordable and supportive for all, we actually have to sort of like step away from our advocacy in terms of how we think we should be solving that. And it's the hardest thing ever to do. We still want to advocate for those things, but that advocacy needs to disappear from the honesty with which we look at our question, because only by really looking at our questions honestly can we begin to realize the moment in which we're certainly just, continuing a practice of harm because we've been sort of like the blinders are on. We're so focused toward the solution that we believe in that we're not allowing ourselves to see sort of like the larger landscape of who might be harmed and what sort of like ill effects can come. So that's the dilemma that we have to wrestle with every day. We're not great researchers if we're not strong advocates for what it is that we do and what our contributions are. But we're also not great researchers if we let it start to sort of like overtake the very way that we examine a problem. Sometimes you come up with something that you realize the very thing that you had faith in, the very thing that you believed in to be right. I think density is one of those, by the way. There's a number of others that are shibboleths in this, but the very thing you believe to be right, that when you allow yourself to let go of that belief, you'll be stunned at what the other consequences they are. And I'm going to give one quick sort of thing. One of the people who's influenced me the most was Gro Harlem Brundtland. I invited Gro to Keynote symposium I put together many, many years ago. And you can imagine the person who basically developed the concept of sustainable development, who's been quoted and misquoted thousands of times over the years. The kind of the mother of sustainability in the world. When she comes, everybody wants an answer from her, and wants her to sort of like say with affirmatively how we're going to fix this world. And she was peppered with questions from the audience, like, if only we could do this, if only we could geoengineer the upper atmosphere, if only we could convince everybody they need to go nuclear, if only we could sort of like get lead adopted. They went through this, and she finally just sort of stopped and said, sustainability is not a goal to be achieved, but a difficult negotiation that you go through every single day of weighing steps of all difficult and problematic consequences, just hoping that you can pick a step that's not as harmful as what we were doing before. That's what sustainability really is sort of like negotiating that difficult path, not sort of leaping forward to the heroic solution that will get us there. So I think about that a lot when I think about this issue of advocacy. No greater advocacy for the world's poor than Gro Harlem Brundtland, no greater advocacy for the world's environment than she is. And the first one to say that you kind of have to let go of thinking that we have these solutions at hand. It really is a negotiation all the way through.
Oh, that's so important and relevant. It's really a process. Another question from the audience. Translational research helps reframe research into wider practice and policies. For example, bench to bedside in medicine and farm to fork in horticulture. Might there be a studio to street opportunity for architectural research, expanding stakeholders and deliverables beyond architecture books and exhibitions?
I love that. I think what I find really interesting in sort of like talking to students who are considering both master's degrees, and we have a large Bachelor of Architecture program, so also students at that level, is how their number one question relates to our role in serving the public and in the community, what we're doing in the community. These are very different questions than students asked, even 5 years ago, but this is what they're very focused on. And I think this is also sort of right in line with what Peggy was suggesting yesterday about that these are the kinds of issues, these are the kinds of problems that we should be testing and experimenting with. And it actually means that it's this generation who's in school now and about to enter school will be the ones that will actually sort of cause us to sort of break that straitjacket. Their desire to see agency, and it's a question about the agency of what you do. Their desire to sort of understand what that is will actually set them up not only better as researchers when they move into research, but will bring that question of contribution right in the beginning. And bringing that into studio is fabulous. But let's do it. Let's just do it tomorrow. Well, okay, we'll have to wait till the fall. Let's do it.
I like that spirit. Yes. So I have a question for you, Michelle, if there's time, if you have time, I guess.
Yeah, no, even though traffic is horrible, it does get a little better tonight. So
okay. So
this is, even though what the image that you're looking at is exactly what's behind me in my office. It's a photograph of what's exactly behind me. So
right.
No, the sun is no longer shining, but
right.
I do it for depth of field. So
these optical illusions. So it was really wonderful to see the images of your early career setting, and those photographs were just really wonderful and meaningful. And I was curious that at one point in the talk, you mentioned, in the setting in Austin, where you're kind of taking students out or going out in the community and looking at properties that are being demolished and turned over for higher density and other issues, that there was a sort of visceral response from one of the young women that, oh, I'm not sure that architecture is what I want to do, because there's this preconception or perception of what architecture is or might be, and then this uncertainty about that role that one might have in the world. And so I'm curious, what was the hinge point for you in your career path to become interested in architecture and shift your passion or weave your passion, I guess, with this discipline?
Oh, it's such a bad story. It probably, and I'm only going to very quickly share it just because it actually shows that I'm an incredibly impulsive person, and then I punished myself by staying with my impulsive decisions for a long time. And one of my most impulsive decisions was getting married at 21, and sticking with it for too long. And part of it involved in-laws that did not like me. The father-in-law did, mother-in-law didn't, and I didn't like. I really didn't like her. That for some reason we had to visit every weekend, and I looked for any way I could spend as much of that it was all day Saturday away from my mother-in-law. And they lived outside of Pittsburgh, and there was a day trip from Pittsburgh to Falling Water. And this is so cliche, I'm embarrassed. I went to Falling Water every time we visited. And my mother-in-law, why do you have to go to Falling Water? And I made up the fact that I wanted to be an architect. And then I'd say after doing it for, get this, 13 years, actually, it was 10. I mean, the marriage lasted for 13, but for 10 years, I was still married when I decided I want to be an architect. One day I thought, I think I really do want to be an architect. So yes, there was a piece of that. I have other than only recovering my pay from industry 3 years ago. So I'm with Peggy on some of this. I'm with Peggy on almost everything she said, other than you know, the huge pay drop I took by making the move. I have loved every single moment of it. I have never regretted the move. I feel like it's opened up enormous worlds for me, but I can't believe it's a Frank Lloyd Wright story. So, we all have interesting stories in there, but yeah. So not researched at all.
You talked yourself into it.
At all. I talked myself into it. I advocated for it for so long. I really convinced myself. Yeah.
That's great. Well, I think if there are no more questions, we really appreciate your time with us this evening, and we welcome everyone to join continued conversation in the lounges, the virtual lounges, through the Hubelo platform. And thank you so much, Michelle. It was a real joy. Thank you so much.
Thank you. And again, I love this conference. I'm so amazed at what you all have put together, and just you know, both the yeoman's work in putting it together, as well as sort of the astonishing sort of like conceptualization of how it was thought through at sort of both levels. It's pretty extraordinary. So thank you. And thanks to all. I think you have to hear from me again tomorrow, but I should be worn out by then. And, you know, and by today, you know, I've had at least 8 or 9 cups of coffee. Tomorrow there will only be about 4, so it'll be less. Yeah.
Perfect.
All right.
See you then. Thank you. Bye.
Bye-bye.